Yeah, good afternoon. This is a case study on the reactive power compensation in the transmission system. So especially we are going to discuss about the merits and demerits, the advantage and disadvantage of reactive power compensation in the transmission system. So normally the electrical energy can be produced from the thermal power plant, nuclear power plant, hydroelectric power plant and some other renewable energy sources. So that can be transmitted from the one end to another end through the transmission and distribution system. So here the reactive power, it plays a major role while transmitting the electrical energy from one end to another end. So here without reactive power we are unable to send the reactive electrical energy from one end to another end. So the reactive power is the most important one to transmit the electrical energy. But even though it should not be very high value and it should not be even zero. So here if the reactive power is high, so here the useful energy should be very less, so that the efficiency is also very less. Suppose if you are minimizing or if you are eliminating the reactive power, we are unable to transfer the electrical energy from one end to another end. So we need reactive power, but it should be within a specified limit, so that if the limit is exceed, the losses, the efficiencies gets affected. So that we have to minimize the reactive power. We have to minimize the reactive power. So there are two types of reactive power. One is inductive reactive power and another one is reactive. One is inductive reactive power, another one is capacitive reactive power. So how the inductive and capacitive reactive power, it compensate the transmission system. So we will see the case study based discussion.
Uh, Hello, my name is Neha and I'm going to say a topic about the voltage profile management. The advantages is that the voltage regulations, by injecting the reactive power at the load end, it can prevent from the voltage sag, and by ensuring that each and every industrial equipment has an operates at its own voltage limit. The next second one is the disadvantage, that is the over voltage risk. At the light load condition, fixed compensation may may lead to the increase in voltage at its safe limits, operating the demands by reducing the insulations in the transformer and the cables.
So I am going to discuss about the transmission efficiency and the losses. The reduction in first about the advantages, the reduction of I square R losses, then the compensation improves the power factor, that reduces the current flows, current that passes through the line for the same real power, and the higher level of voltage leads to the higher level of heat losses. And next about the disadvantages, the cost of implementation is higher. So next about the capital expenditure of the power system requires the long term POI analysis for the installment.
I will talk about the system loading capacity. System loading capacity means how much a power transmission line can carry safely. The main advantages is more power transfer. When the voltage is stable, the line can carry more power without any problems. So we can use the system more efficiently. But there is also a disadvantage, that is maintain a difficulty. Capacitor bank are used to control a voltage, but there is which create a small disturbance. This can damage a equipment like a circuit breaker over time. So it's need to regular maintain and monitoring, which increase the effort and cost. Finally, it is useful for increasing power, but we need a proper maintenance to handle the issues.
Tell about the focus of system stability and dynamics. Advantages: enhanced dynamic stability. The compensation devices like StatComs can be used to identify the voltage grip faults, and then it can rectify in a millisecond to helping the system remain synchronized after a disturbance. And then the main disadvantages of this StatCom devices like means it can introduce a harmonic system which added a filter to the necessary of the system.
I am going to talk about the environmental and operational footprint. The important advantages of deferred infrastructure upgrade. This means by improving efficiency of existing transmission line using compensation techniques, we can delay a new transmission tower, and it is helps to reduce environmental demand and saving cost. However, there is also a disadvantage, which is space requirement. Long compensation substations are needed, a lot of land requirement, and it is difficult, especially in cities or economical protected areas.
About economic impact on I'm Kanishka, and my point is about economic impact on utilities. If the power factor is low, the utilities must pay the penalty charges. Reactive power compensation improves the power factor, and it keeps the power factor above the required value. This helps to save the money and also reduce the cost. And coming to disadvantages, control strategy risk. Automatic compensation can lead to power factor, and automatic compensation can create a good better decisions, and if the control system fails, an entire system fails, problem can cause us sudden emergencies. And it also called hunting is nothing but it can create a voltage change. Thank you.
Normally, in reactive power transmission, so it plays a major role for the compensation of reactive power in the transmission system. So without reactive power, we are unable to transfer the electrical energy. Suppose if the reactive power, it contains more amount of either inductive reactive power or capacitive reactive power, so definitely it will affect the power factor. Once the power factor gets affected, so we have to pay the severe penalty to the suppliers. So that is as well as the consumer. This based on the where the power factor gets lagging. So there are two types. There are three classification. One is shunt compensation, series compensation, and third one is the combination of both shunt and series compensation. So here the shunt compensation, like a StatCom, it is a static compensator. So it will be connected in the parallelly with the transmission network. And for the series compensation, we may use a TCSA. So thyristor controlled series compensator can be used. So it can be connected in series with the transmission network. And both the series and parallel combination, we may use either UPFC or UPQC. That is a UPFC, Unified Power Flow Conditioner, can be used in the transmission network, and a Unified Power Quality Conditioner can be used in the distribution system. So here UPFC for high level voltage and UPQC for distributed low level voltage. So that can be used. So it is mainly to maintain the voltages stability. That is nothing but and power system stability. So if you want to maintain the system as stable one, stability, so here we have to avoid the transient and oscillatory movement condition. So definitely we have to maintain the stable condition. So for that we have to use this kind of flexible AC transmission system, that is called, which is called a fax devices. So such kind of fax devices can be used to maintain the system as stable. So these are, here we are discussing the case study on the advantage and disadvantage of using the fax devices in the transmission network by supplying the reactive power compensation. Any queries? No, thank you.